All right, in this video, we are going to talk about factoring something called the difference of two squares. The difference of two squares is a two-term expression that looks like this: a squared minus b squared. And if it factors into this product here, which is not immediately obvious if you've kind of forgotten how this works. It's a plus b times a minus b. So a lot of people, when they see that, at first they kind of doubt that. But if you take a look at how this works and you multiply this out, it kind of tells you, uh, gives you a little insight into why that's so. Now, to multiply out some expression like this, and there are other methods, but one of them is FOIL, right? First times first, right, is a squared. When you multiply that, you would multiply this a times this a and get a squared. And then the O in FOIL stands for outer, right? So you would multiply a times minus b, so that would be minus ab. And then inner times inner, right? The I in FOIL stands for inner, so that would be plus b times a. So you can write that as plus ba. And then the L in FOIL stands for last, right? So plus 1b times minus 1b is minus 1b squared. Okay, so because you have a positive here and a negative here, so it comes out to be a negative. So you can see the a squared and the b squared. The thing is that this ba, right, because multiplication is commutative, right, the order in which you multiply two real numbers doesn't matter, you can rewrite that as ab. All right, and then you have now these terms being like terms. I have negative 1ab here and positive 1ab here, and a negative 1 plus a positive 1 is 0. So I'd have 0 ab's, right? Well, that's just 0. So these, which I'm not going to write here. So these terms cancel each other out essentially, right? And you're left with this b squared right here. So that's the situation. It doesn't, at first you might say, when I factor this, it looks like there's more stuff than was here initially, and you're kind of right in the sense that there's a lot more symbols here, but if you take the time and multiply this back out, it definitely multiplies out to be this a squared minus b squared. Okay, so so that's why this formula works, and this formula is called the difference of two squares, right? It's really the only special product that we're going to talk about for now. You might say, well, where's the sum of two squares, right? With the sum of two squares, it just doesn't work out. If I have a squared plus b squared, all right, it doesn't work out to what you might think it works out to, right? A lot of people will say, was that a plus b times a plus b, but the answer is no, it is not, right? It's not this. Because if you take the time to multiply this out, right, you get a squared plus ab plus ab plus b squared, right, using that same method that I showed you, right, because everything's positive. I get ab here, and that simplifies to a squared plus 2ab plus b squared. Okay, so you can see that and this other sum of two squares doesn't work out. Okay, so for right now, what we say about the sum of two squares is that it's not factorable, which is actually, I'm kind of lying to you about that. It actually is, but it's just better for right now that you think that it's not. Okay, and I used to hate that when teachers would say that to me, and the thing is that you can factor this, but you need complex numbers, which we're not ready to talk about yet. Okay, so that's the truth. All right. So for right now, thinking that it's not factorable is actually maybe a little bit more beneficial. Okay, so what we need to be able to do then is, at the very least, right, is to factor the difference of two squares, right? it's pretty easy to spot when you might have this situation because you only have two terms over here, right? So with four terms, factor by grouping. With three terms, you would try the AC method or whatever method that you're using, and then for two terms, you would try the difference of t-squares. Okay, so so let's factor 64 minus x squared y squared. All right, so normally what I do and what I tell people to do is, if you think something's the difference of t-squares, then write it as the difference of t-squares, or try to write it as the difference of t-squares. And the main thing with the difference of t-squares is, right, it has to be something squared minus something else squared, right? So if I'm trying to apply that formula to some other expression, I write it like this. I'll have something squared minus something else squared. Right? And then I try to figure out, what would I put in parentheses here? What would I put in parentheses to get a 64? Right? And then most people can pretty quickly say, oh, well, that would be 8, right? Because 8 times 8 is 64. And they'd be absolutely correct, right? Over here, think about, hey, what would I put in parentheses here to get x squared y squared, right? And most people would say, right, what about xy? Would that work? And the answer is absolutely that would work, right? Because of the fact that that is directly equal, right? xy quantity squared, using the properties of exponents, right, is x squared y squared exactly, right? So we would get exactly this. All right, so try to write it as the difference of two squares. And the benefit to me of doing it this way is now you know exactly what will play the role of A in this formula over here, and what will play the role of B. So playing the role of A in this formula over here would be 8, and playing the role of B would be x times y. All right, and so then you're able to easily say what the factored form is, right? Because it's going to be A plus B, so that would be 8 plus xy times 8 minus xy. Okay? So once you identify your A and your B, then you can just kind of go with this pattern and write it out like that. All right? So that is the difference of two squares. All right, and that brings us to, now that we've talked about all of the reviewed kind of the techniques that we need to talk about, that brings us to factoring completely. To factor a polynomial completely, in some of the directions in the assignment problems that you'll have to work, and on the test will say factor completely, right? You should follow the following steps, and we've talked about these steps all, right, in a previous video. So first step in factoring is always pull out the greatest common factor. That'll bring the numbers down, right, and make what you have to factor more simply. Once you factor out the greatest common factor, right, if there is one that's other than 1, is look at the number of terms, right, that the polynomial has. If it has 2 terms, in other words, called a binomial, try to use the difference of two squares, okay? If the polynomial that you have left after you factor out the greatest common factor has 3 terms, in other words, it's a trinomial, try using the AC method that we talked about in the previous video. And if the polynomial that you have has 4 terms, right, then try factoring by grouping. All right, so these are guidelines, right? In the big picture, then things are really complicated, and you know this is not always going to work out. And but for the problems that you're given, right, on the assignments and on the test, right, in this class, these will work out. And then when we get to some of the more complicated ones in a later chapter, we'll have different techniques that we use. Okay. All right. The other thing too about factoring completely is, just because you factor something into a binomial or a trinomial, right, doesn't mean that you're done factoring. Sometimes you'll have things break down even further, okay, than that. So what you want to do is repeat those questions or this process for each one of those factors that you get. So let me do a quick example of that. An example of something where you might have that situation would be something like x to the fourth minus 1. If somebody told you to factor that one, you would say, okay, well, greatest common factor is 1, right, of these terms. So there's no greatest common factor to remove. And I have 2 terms, right? So what I would do is try to use the difference of 2 squares. Can I write this as something squared minus something squared? And the answer is certainly yes, right? For x to the fourth, right, that is x squared squared. Okay? And then for 1, what would I put in parentheses here to get 1? And that would certainly be 1. 1 squared, right, is 1. So it is the difference of 2 squares, so I know that it would factor into x squared minus 1 times x squared plus 1. And so I have factored this, right, but I have not factored it completely. Because what you want to do is make sure that these don't factor here, right? In this example that we did up here, 8 plus x times y, 8 minus x times y, that is not the difference of 2 squares, right? And it's not a trinomial, and there's not 4 terms in here. So that can't be factored any further. But in this problem, right, this x squared minus 1 is the difference of 2 squares, and it does factor to x minus 1 times x plus 1 using the difference of 2 squares. This other term, x squared plus 1, is the sum of 2 squares, right? So for right now, we are just saying that that does not factor, even though in reality it does. It's just more complicated than these. Okay, so that's what I mean by factor completely. Make sure that you break down each of these factors. Okay. All right, that is it for this video.